Okay, let's get started. And like I said, the first thing we'll do is we're going to look at the checklist planner. I'll say a few things about the test though, because it wasn't due until 11:59 last night. I haven't yet started to grade the tests because I have to go in and grade your work on the problems that required you to show work. A few of you have emailed me about different things with the test. I'm trying to email you back as quickly as I can. So I will continue to deal with that during the day today. I hope to get all of them graded by next time we meet, so by Monday, okay? But if you sent me an email about something, then please check your email right after class today. And hopefully I'll have a response to everybody who had a question about something. You can ask me questions too about the test during the break today. So if you have a question about that, hold on to it, and during the break today, just stay on and I will spend the break answering those questions. So we are starting a new chapter. So let's look at the checklist for test 2, which will be over chapters 3 and 4. So this is your checklist planner. If you did not print one of these out for the first test, I encourage you to do so for the second test. And so I have some tips on these checklist planners, and also you can see that there's a place for you to put the grade for every quiz and homework that count towards your grade. So you see today that of course, I have attend class if you can, or watch the recording. And then we have two things we're going to talk about. We are going to talk about the Chapter 3 Skills Review quiz. You do have to do the Chapter 3 Skills Review before it will open up the 3.1 homework for you. And Chapter 3 is all about probability. So let's talk about I'm going to talk to you about what that is for a minute, and then we're going to talk about the Chapter 3 Skills Review. So probability is a very important part of statistics. And what we're going to be doing in Chapter 3 is learning about just probability. Then we're going to use what we learn about probability and see how it's applied or how it's used in statistics. So this is sort of a side thing, talking about probability, but it is super important because you can't interpret statistics unless you know something about probability. So this unit, it's sort of an aside. Let's learn about probability so we can do more things with statistics. And that's how we're going to go forward, okay? Let's see. We're going to start with, I'm going to pull up, I have several examples from the Chapter 3 Skills Review, and that's what we're going to start with. That's okay. The Q in front of that, remember, means that does count as a grade. It counts on your quiz average. The skills review assignments all count towards your quiz average. So the Chapter 3 Skills Review is what we're going to work on first. And I have several examples. I'm going to go through some of them pretty fast because they're fairly easy. I'm hoping to actually get to 3.1 before the break because 3.1 has quite a bit of stuff in it. I did put the PowerPoint is mainly what I'm going to go through on that because we are going to get some definitions to start Chapter 3. And so that's what we'll be doing. That's definitely what we'll be covering after the break today. So let's do example 1. So like I said, I'm going to do several examples from the Chapter 3 Skills Review. So you should write these down, or you can do them with me if you have your Chapter 3 Skills Review homework open. And you can see this one, I just got problems out of the actual quiz. See, this is number 1 in the Chapter 3 Skills Review. And I'm making it larger on mine so that I can see it. You may want to enlarge yours too, remember with the little magnifying glass. Now I'm going to give you a second to try this on your own. See if you can remember anything. This is about exponents. And just to remind you about exponents, an exponent looks like a superscript. So if you saw something like this, if you saw 3 to the 4th power, that 4 is the exponent. And what 3 to the 4th power means is 3 times 3. It tells you how many times to repeat 3 as a factor. Now what they're wanting you to do on this problem is write this. This is in factored form. So what they have here is called factored form because it's written as a product. So factored means written as a product. I should probably use the type tool instead because my writing's not so great. Factored means written as a product. So this right now is in factored form. What we want to do is write it in exponential form. So when we write with exponents, that's called exponential form. And they want us to write this in exponential form. So I want you to see if you can figure out, if you're in my stat lab, go ahead and try this problem in my stat lab. If you're not, write the problem down and try it on your paper. I'm going to call names. I'm going to go ahead and call roll. Raise your hand and leave it up until I'm done. Today is 9/23. It's fall now. The weather feels like it for sure. Okay, Ariana, Cecil, Diamond, Kayla, Kendra, Christina, Samira, Stephanie, Jacob, Temperance. Temperance, are you there? All right. Okay, you can put your hands down. Thank you. So now we're going to look at this and see, remember I'm not actually in my stat lab now. This is a picture of it, okay? So I did screenshots of different problems. So you're not going to see me actually put the answer in, but this allows me to write on it and help you take notes. So on this one, first notice the 1 is repeated 3 times. So the first thing they want you to do is write 1 to the 3rd power. Did everybody do that? Times. And then we have, let's do these in different colors just for fun. We have 5. How many 5s? 1, 2, 3. I have 4 5s. So 5 is the factor. It's repeated 4 times. Times. And then it looks like we only have 1 6. So you're going to have only a 6. And you could put a first power on there if you wanted to, but I don't think it will count it wrong if you don't. Because when you don't see a power on something, it's understood to be a 1. So it shouldn't count it wrong. You should be able to leave it without a power. I think if you put a 1 there, it should count that right too. If you want to play around with it, you could check and see. Really, both of them should be counted right. And then on this last one, let's see how many I have. 1, 2, 3, 4, 8. So 8 is the factor. It's repeated 4 times. Notice it says do not simplify. So they don't want us to figure out what this is equal to, although we could in our calculator. They just want us to write this. Raise your hand if you got that one. If you did that one and you got it right, raise your hand. Good job. Christina, and who was the other one that said they did it, Cecil? Diamond, good job. Very good. Okay, so that's one example. Great. Okay, let's do example 2 now. So this chapter 3 skills review is going to go over a lot of different skills that we need in order to do probability questions. And one of the things with probability is that probability can be written as a fraction, a decimal, or percent. We've practiced this before, but we're going to practice it again because we're going to be using it a lot. This one wants you to write an equivalent decimal or a decimal approximation. So it's written in fraction form right now. Written in fraction form right now. They want us to write it as a decimal. Can anybody remember? We've talked about this before. Can anybody remember? Type in the chat if you can remember how to change a fraction to a decimal. Does anybody remember how to do this? How do you change 17 over 23? What does that mean, 17 over 23? What does the fraction bar really mean?
To divide.
To divide, exactly, Kayla. So on this one, when you see 17 over 23, it means, and you don't put the bigger number first, it's always the top number divided by the bottom number. So what that means is 17 divided by 23. So if you do that in your calculator, I'm not expecting you to do that by hand. We're not going to do long division here. We're going to divide in our calculator. 17 divided by 23. And I can't see my, and I got 0.7, I'm going to take it out several places. 7391. 7391.3. That should be far enough. So let's look at their rounding rules to see what they want us to do. It says type a whole number or decimal rounded to the nearest thousandth. I'm going to show you how to figure out what place these are if you don't have your places memorized. 1,000, you know, is one, looks like that. That's 1,000. Notice how many zeros there are. That's how many places you're taking it out. So the 9 is in the rounding place. That's the thousandths place, which means everything else is going to chop off. But we are going to look at that 1. Here's some little eyeballs. We're going to look at that 1 to decide what to do with the 9. Since the 1 is smaller than 5, that means we are going to keep the 9. If it was 5 or bigger, we would add 1 to the 9, which would have meant if we had to add 1 to the 9, we'd have to change it to a 10, and then that would make the 3 become a 4. But since that's just a 1, that means we're going to keep the 9. So our answer here is going to be 0.739. Any questions? Don't forget to put the top number first. It has to be the top divided by the bottom. Okay, let's do another example. This one is about graphing inequalities. You can notice that this is number 9 in the Chapter 3 Skills Review. And it wants us to graph this, and it says W. W is just a variable that represents something. I'm going to write that bigger over here. And basically what this is saying is if I read it from the W, I'm going to read to the left. Let me get my little hand here. To the left, it says W is greater than 0. And if you read to the right, W is less than 12. So basically, W is between 0 and 12. Now, because there's no lines under the arrows, notice these arrows do not have lines. That means that we're going to use parentheses instead of brackets. So when you have, I'll write it down here. When you have this or this, you're going to use parentheses. And when you have brackets, you're going to use, I'm sorry, use brackets. Okay, let me write this different. Use brackets with when it's this or this. If there's a line under it, that means the number is included in the solution or the interval. But on this one, when there's no lines, do y'all see that? There's no lines under these arrows. Right here and here, there's no lines under the arrows. That means 0 is the start and 12 is the end, but 0 and 12 themselves are not actually included in the solution set. So what we're looking for, and it looks like I didn't get the entire picture here, answers B and D. Hopefully A or C is the right answer. So I don't know why it does that, because on the picture it looks like, oh, let me try something and let me see if it shows the whole thing. Nope, that didn't have, oh, maybe if I do, oh, there I go, there I go. Okay. So I'm looking for an interval for W. I'm looking for an interval of W showing the numbers between 0 and 12, but not including, which means I'm using parentheses on this one. So this is going to be the right answer right there. That A is going to be the right answer. Christina, do you have a question?
No, it was an accident. Sorry.
It's okay. All right, moving along. Are you guys getting this? Everybody raise your hand if you got that. Great. So 5 people. Okay, keep your hand up so I'll know for sure if it's everybody. Raise your hand if you got that. Cecil, Jacob, Kendra, Temperance, did you guys understand it? Be sure and raise your hand while we're going over one if you have a question. That was example 3. Let's go on to example 4. So there are several questions like this one. Okay, you can put your hands down unless you have a question. Ariana, did you have a question? Thank you. I'm just making you exercise. Put your hand up, put your hand down, put your hand up. All right, guys. So there's several questions. This one happens to be number 12. There's about 3 or 4 of these in the skills review where it wants you to translate the verbal phrase into a mathematical expression. So this is going to involve figuring out what symbols to use for things. It says the measure of the particle m, so they're telling you what variable they want you to use for the measurement of the particle. This says is exactly 21 millimeters. So for ours, if we were going to do that, when it says it's exactly 21, that just means it's equal to it. So this one would be M, and that should be lowercase. I don't know why it looks like a capital M, but it should be lowercase. Let me see if it'll let me do lowercase. There. M, because you want to make it match, and I need an equal sign. equals, and I need a number, equals 21. Now, they're going to say different things. They're going to say, let's put some of the other things they might say. If they said less than, then we would use this symbol. So you're going to try to use the right symbol. This particular problem just says is exactly. So exactly means equals. If it said less than, you would use a less than sign. Greater than, of course, would be greater than. If you said something, if you saw at least, that means if you say that thing weighs at least 50 pounds, okay? So say I wanted you to say the weight of that rock, the weight of the dog is at least 50 pounds. And they might tell you what variable to use. Maybe they say use a W for weight of the dog. So the way you would write an expression for that, at least, now when I read that to you, you know what I mean. I mean that dog weighs 50 pounds or more. But 50 would be included. So the correct symbol would be greater than or equal to 50. And that's what that would be. So you're going to run across different expressions and you're going to want to translate them into math. So be sure if you have a question about any of those and you're not sure what symbol to use for it, then don't forget you can view an example or help me solve this and then do another one. So we're going to have different things there. Those are some common ones. We did exactly, that's equals. We did less than, greater than, at least. So at least would be greater than or equal to. At most is going to be less than or equal to. I can't remember. I'm trying to think if there's. Sometimes you'll just see the word is. Like it won't say exactly. It'll just say is. That would be equals. So be sure and go through those and get used to the words and how to write the statements as a mathematical expression. Okay, let's go to example 5. This is something that you may not have seen before. When in math, an exclamation point, so this, I'm going to draw this bigger. This problem says 5, and then it's an exclamation point. In math, that does not mean say the 5 with emphasis. In math, an exclamation point tells you that's called a factorial. And the way you would read this is 5 factorial. And when you have in general n factorial, Christina?
I don't know why it keeps doing.
So in general, if you have n factorial where n is any number, that means it's a product. A factorial is a product, meaning you're going to multiply things together. So n factorial means n times, and then you're going to multiply by 1 less, and then you're going to multiply by 2 less, and then multiply by 3 less, and you keep going until you get down at the end until you're down to, at the end you'll have 2 times 1. So you'll have it all the way down to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. Now in reality that 1 doesn't really do anything, so you don't have to punch that into your calculator. So this would give you equals, and I could multiply this, and you can do it in groups. Like you can do like the 5 times 4 is 20, and the 3 times 2 is 6. So 20 times 6 is 120. On your calculator, there is a way to do a factorial on your calculator. I'm going to want you to know to show this work on the test. So I'm not going to show you on the calculator right now, but I will show you in another session how to do a factorial in the calculator. For now, I want you to multiply it all out so you'll know exactly what a factorial is. And another thing you just have to learn is that 0 factorial. I'm sure you want to say it's 0 because that's what it seems like it ought to be, but it's actually 1. So this is a thing you have to remember. So it's just remember this, just memorize. Even though it goes against what you probably feel, 0 factorial is 1. And I think that's one of the questions in the skills review. All right, so that was example 5. I have 9 examples total for the skills review. This is example, I can't remember which one. Oh, 6. Okay, this is example 6, and it's number 20 in the skills review quiz. This one says evaluate n minus 1 factorial for n equal 9. Anytime you're given a value for a variable, that means take that expression. If n is 9, then n minus 1 factorial becomes 9 minus 1. And notice the factorial is outside of the parentheses. That means you're going to do what's inside the parentheses before you do the factorial. And then remember from the last problem, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, the 1 doesn't change the product, so you don't actually have to include it. So I want everybody to do 8 factorial. Type in the chat when you get the answer. Does anybody have it yet? Very good, Cecil. Good job. So factorials are pretty easy. You guys just have to remember what that symbol means. Okay. So we're going to have some factorials in some of our formulas in this chapter. That was example 6, so we're going on to example 7. Diamond, do you have a question?
I was trying to see how did y'all get the answer for the last one?
We multiplied in our calculator 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
Okay, so you do multiply all the rest of them as well. Okay.
Yes, yes. Okay, now notice this is a factorial expression, and we're going to get answers like this to some of our problems in chapter 3. So that's why we're going to practice this now. And what I want to show you here is that there's an easy way to do this when you're dividing a factorial by another factorial, especially when the top one is bigger. Then this is pretty easy, and I'm going to show you how to do it. So on that top one, 27, I'm not going to count all the way down to 1, okay? I'm going to count down to 23. So 27 times 26 times 25 times 24 times, now the rest of that, guys, I'm just going to call 23 factorial. That would be 23 all the way down to 1. And then what this says is that that's divided by, and on the 23 factorial, I'm just going to keep that. Because notice now that I have a 23 factorial on the top and the bottom, those cancel. As if you were simplifying a fraction, which is what we're doing. And then what remains is this. So to get the answer, I just have to multiply those 4 numbers together. So multiply those 4 numbers together for me. and type in the chat what you get. Last time Cecil got the answer first. Don't let him beat you again. So Cecil, he got first one time. What's going to be the answer on this one? So the 23 factorials cancel. Christina, she beat you, Diamond. Christina typed, 421. So she has a point. 421, 421,200. Numbers get really big when you're multiplying, don't they? Okay, so we have Cecil and Christina both have a point. I may have to figure out a way to do something with this later. Okay, so that was example 7. Let's go to example 8. On example 8, notice this is number 25 in the quiz. We have 12 factorial, but notice we have 2 factorials on the bottom instead of just 1. So what you're going to do in this case is you're going to count down to the larger of these 2, okay? So since 10 factorial is bigger, on the 12, I'm going to do 12. Hold on a second. My pen's freaking out on me here. And I'm only going to count down to the larger of these 2 down here, and I'm going to call the rest of that one 10 factorial. Now on the bottom, that 10 factorial matches this other 10 factorial, so I'm not going to do anything with that 10 factorial. But on the 2 factorial, now it's only a 2, but I'm going to count down on it to show you that because I kept the 10 factorial on top, I am going to cancel it with this 10 factorial down here. But whatever this one was, like if it had been a 3 factorial, I'd have to put 3 times 2 times 1. So when you have 2 of them on the bottom, you're going to keep the bigger one, but the other one, you're going to write the factors out. So now what I've ended up with is I've ended up on top with 12 times 11. And on the bottom, I have 2 times 1, which is just 2. And now I'm going to do 12 times 11 and divide by 2. Or you can cancel, if you guys know how to do this. I know that 2 goes into 12 6 times, so I can cancel that 2 into the 12 6. There you go, Cecil. He won. I didn't even ask a question yet, and he got it. So you got 6 times 11, which is 66, just like Cecil said. Good job. You guys are going to have to get faster. Okay, so the answer on that one is 66. Let's go do the next one. And we're going to do factorials again when they come up, but it will already be in your head at least. This was example, what example was this? This was 8. So we have one more. So we're going to be able to start 3.1. Example 9. Last example for this skills review. And this has to do with your calculator. So if you don't have your calculator, I need you to get it. Have your calculator ready. And we're going to talk about the printout or the readout, the display that your calculator gives. Sometimes when you have very, very large answers or very, very, very small answers, it will put it in scientific notation. And that's what this is. Scientific notation looks like this in the calculator. So what I want to talk to you about is what that means right there. And this is calculator. This is what the calculator will write. What they want is the correct mathematical form of the scientific notation. So I'm going to tell you what this means. Scientific notation will have a decimal number times 10 to a power. That's scientific notation. So I'm going to give you an example. If I had 25,761, and if I wanted to write that as scientific notation, okay, I would call it, you move the decimal point after the very first number. So it's equal to 7.5761 times 10 to the, and now I have to figure out how many places I moved the decimal. So the decimal needs to go 1, 2, 3, 4. So that's times 10 to the fourth. So this problem right here means 7.35311. I think that's a 7. And that E6 means times 10 to the sixth power. This is what they want in the blank. They want you to write it like this instead of this. So that E6 there means this. Sometimes they'll give you a negative, like, let me see, if you get a really tiny number, like, let's do this in your calculator. Do 2 divided by 5, 6, 7, 8, 9. Do that in your calculator. And in the calculator, it will say this. For an answer, it will give you this. It will give you 3.521. And then there's a bunch of numbers, a bunch of zeros. And then it says E, and then you'll notice it says minus 5. That's because 2 divided by 56,789 is a very tiny number. And so what this is telling you, this E minus 5, that means this is 3.521. I'm just going to drop the rest of that. I'm going to round this a little bit. Well, I guess I can put it 1, 2, 3, 4, 5 there. Times 10 to the minus 5 power. That's what that E minus 5 means. It means the power on the 10 in scientific notation is negative 5. And what that tells you is that the decimal point needs to be moved 5 places to the left. So when that number is negative, that means the decimal point belongs to the left. You need to make the number small. 1, 2, 3, 4, 5 decimal point. And I'd have to fill those in. So that means that that number is really point. And then you see I have 1, 2, 3, 4 zeros, the 3. That's what that really means. So when you see E minus 5, that means the decimal point needs to be moved to the left. And on this one, since that says E6, that means move decimal 6 places to the right. But what they wanted, they just wanted the correct scientific notation. So they don't want you actually to move the decimal point. They just want you to write it like this with the power of 10. So let me write that again, what the correct answer was on that one. So the correct answer that they want in this blank is 7.353117 times 10 to the sixth. That's what they want in the blank. So they just want you to change the E6 to this. Okay, we have time before the break to do a little bit in 3.1. Before we do that, I want to encourage you to print off the formula sheet. I don't know if there's anything on the formula sheet from 3.1, but you should print off your checklist planner and your formula sheet for Unit 2. So the formula sheet, let me see where that is. The formula sheet looks like this, and yeah, 3.1 isn't on. These formulas are formulas that start, I believe, in 3.2. So as long as you print it off before you get to 3.2, you'll be fine. So we're going to go on to section 3.1. And I do have the PowerPoint that I'm going to go through for a few definitions. 3.1 is an introduction to probability. Sorry, I'm looking for my blue. So the other thing we're going to do is 3.1 homework, and this is an introduction to probability. Before I go into that, I would like to say a few things about the class in general. I think I'm probably going to send an email out about being successful in this class. And of course, doing the homework is instrumental, very important. But guys, there are other things that are really important for you to do to be successful in this class. Those things include reading all the announcements that I put up, reading all the emails that I sent to you, and reading instructions that I give you. So for example, for test 1, I provided instructions and a practice. Anytime I give you something to practice with, I give it to you for a reason. I give it to you because I know students need to practice something before they do it. So when I put the Proctorio practice quiz on there, I put that on there because I knew you needed to practice with Proctorio before taking the test. Even if you've used it before, even if you've taken online classes before, you still need to, if I provide a practice for you or information for you, I need you to read it and I need you to follow it. And I gave instructions for test 1. I need you to look at those, print it off if you can. But if you can't print it off, then take notes from it, the things that you need to make sure you do before taking the test. So I have found that students who are successful in my class, okay, one way to be successful is by reading everything I give you. So when you have time, go back to Blackboard, click on every single thing in the menu, and read everything that I've given you. I spent a lot of time trying to think about what I could provide for you in Blackboard in case you couldn't come to the live class, or because we're online, what can I provide there, information that will make the class easier for you. So take advantage of that, okay? Take advantage of the things I've put time into it to try to help you. But if you don't read it, it won't help you, okay? So I encourage you to go and re-examine that Blackboard course. Look at everything I've put in there. Read every piece of information that I've given you, top to bottom. All right? And if you have a question about something, let me know. All right, we're going to go on to an introduction to probability. And like I said, I did put the, I have the PowerPoint. Kendra, do you have a question? Hey guys, when you're looking at this, can you see the whole thing? Do you see the picture of the world, or do you only see where it says chapter 3 probability?
I
The whole
see the
thing.
You can see the world.
Oh, you can see the world? Okay, great. Okay, I'm going to ask you a question. So stay on for a second, okay? Okay, now can you see the world?
yes.
You can. Okay. Okay, I'm just trying to compare what I see to what you see. Okay, thanks. Chloe, is there a question? Okay, let's go on then. So we're looking at this. We're going to do section 3.1, which is the basic concepts of probability and counting. And first we start off with some definitions. So let's look at these, and I'm going to stop every once in a while and show you some things about these definitions. So first definition here, and you don't need to write these all down now. This PowerPoint is available to you in the media. So the 3.1 PowerPoint.
Miss Catherine, can you hear me?
Yes.
Okay, sorry. I was struggling before with my headset. It wasn't working for the speaker. I'm sorry.
That's okay.
So yes, can you, I had a question, but it's okay. We can go ahead with the presentation, and then during the break, I'll ask.
Perfect. Okay, that will work. So guys, if you don't want to write all this down now, I totally understand. But if you'll go to the PowerPoint, can be found in the media assignment for 3.1. So if you want to go look at this more slowly and look at the different things, then that will be fine. So first, let's just go through some of these definitions really quick. A probability experiment is an action, a trial through which specific results are obtained. And I'm going to give you an example of that in a minute. An outcome is the result of a single trial in a probability experiment. A sample space is the set of all possible outcomes. Make sure you know that definition, so at least write down in your notes that you need to know what a sample space is. It's a set of all possible outcomes, and an event consists of one or more outcomes and is a subset of the sample space. Okay, now I'm going to switch back to camera so that we can talk about a probability experiment. So I'm going to erase this. And let's talk a little bit about a probability experiment. Let's do a really easy one. A probability experiment. Let's say flipping a coin. That's a probability experiment. And maybe you flip the coin a certain number of times, but you're flipping a coin to see what the outcome is. And we call the outcomes for flipping a coin heads and tails. And we're going to assume this is a fair coin, that it's not weighted or in any way. And so sample space, remember I told you this is a definition you need to know. And they'll often call the sample space capital S. It's a set, so we're going to use set notation, which means braces. And the sample space is just a list of all possible outcomes. So the possible outcomes are heads and tails. Now, usually when we're doing probability experiments, we come up with abbreviations for the outcomes because we don't like writing that much. So another way we might write it is H and T. So that's what a sample space looks like. So let's look at some more things. We're going to look at more examples of some sample spaces. Oh, we have, yeah. We'll have another example of that in a minute. We have one more definition here, the fundamental counting principle. This is something we're going to learn how to use. You don't need to write this down right now. That would take up too much time. But we're going to look at how it's used on an example. The fundamental counting principle is a way of determining how many ways things can occur if you do more than one thing, more than one event. See, it says if one occurs in m ways and the second event can occur in n ways, then the number of ways they can both occur in sequence is m times n. I'm going to show you what that means here. So suppose we're flipping a coin, and there's our sample space. So two outcomes. Two possible outcomes for flipping a coin. And let's say we also roll a die. That's one of a pair of dice. And for that, your sample space is the numbers 1 through 6. A normal die. There are dice that have more than 6 sides, but most of them have 6 sides. So your possibilities are the numbers 1 through 6. So we have 2 outcomes for the coin, and we have 6 outcomes for rolling a die. Then if we do both, so say we do this, then roll a die. Then what is the total possible outcomes? And this is what we mean by that. So remember, we could have gotten heads or tails on the coin. And then if we got heads on the coin, we could have gotten 1, 2, 3, 4, 5, 6 on the die. Or if we got tails on the coin, we could have gotten 1, 2, 3, 4, 5, 6, any of these on the die. This is called a tree diagram, where I'm showing all the possibilities. So my possibilities, like this one is getting heads and then a 1. This one is getting heads and then a 2. This one's getting heads and then a 3. So do you see how, and all together, notice I have, there's going to be 6 possibilities here and 6 possibilities here. So a total of 12 possible outcomes for the sequence of events. Now, to use the fundamental counting principle, will give us the total number of possible outcomes without drawing a tree diagram. Because all we have to do is take, okay, so the first event in the sequence was 2, had 2 possible outcomes, and the second event in the sequence had 6 possible outcomes. So the fundamental counting principle says that if we multiply the number of outcomes of event in the sequence of events, that will give us, that's the total number of possible outcomes for the sequence of events. So we could have written them all out like this. They would have been heads in a 1, heads in a 2, heads in a 3, heads in a 4, heads in a 5, heads 6, tails in a 1, tails in a 2, tails in a 3, tails in a 4. I should make up a song. Okay, but there would be 12 possible outcomes, 12 possible combinations of outcomes if we had this sequence of 2 events. And that's how the fundamental counting principle is used. So let's look at another example of that. And then we'll stop for the break. So I have another example that they give us. So this one is an example of using the fundamental counting principle. And this is in the PowerPoint. You can tell that because it says Pearson. It says you're purchasing a new car. The possible manufacturers, car sizes, and colors are listed in the table. So you see for the manufacturer, we have 3 choices: Ford, GM, and Honda. And then for the car size, compact or mid-size. Maybe these are the only ones you're considering. And then for the color, white, red, black, and green, 4 possible colors. So it says, how many different ways can you select a manufacturer, a car size, and a color? And it says use a tree diagram to check your result. So they want you to first use the fundamental counting principle. So we had 3 manufacturers. So I'm going to write 3 down. I'm going to show this to you in a minute. 3 manufacturers. And then for the size of the car, we had 2 possibilities. And then for the color, we had 4 possibilities. So I'm going to stop sharing so you can see, everybody can see the board. So 3 manufacturers, 2 different sizes, 4 different colors. Using the fundamental counting principle, I can get the total number of combinations of manufacturer, size, and color by multiplying those 3 numbers together. So that's 3 times 2 is 6 times 4. There's 24 different possible cars based on manufacturer, size, and color. Now they said to check it with a tree diagram. Drawing a tree diagram for this is not that easy, but we could do this. Remember the manufacturer was Ford, I believe it was GM, and Honda. So there's our manufacturers. Tree diagrams can also be drawn this way. So you could go Ford, GM, Honda. Okay, that's another way you could, and then your tree goes that way. This tree is going to go down this way. For the size, I had compact and what was the other one? Mid-size or something like that. So compact and mid-size. So each of these go like this. And then our colors, I forgot what the colors were. Let's look at the colors again. The colors were white, red, black, and green. White, red, black, and green. White, red, black, and green. So that means from here, each of these splits into 4. White, red, black, and green. This is why the tree diagram is harder, because it's hard to have enough. Can you imagine if you had like 10 colors or 10 manufacturers? This gets really hard to draw the tree diagram. White, red, black, and green. And so you can see I'm going to have, I have 4, 4, 4, 4, and you're going to have 4 more here and 4 more here. Okay. And so if you were to count everything along the bottom, so here's one combination, there's another one. And if you counted all the possibilities, so like this would be Ford compact, a white Ford compact. This one would be Ford compact but red, a different one. So each of the things at the bottom represent a different car. And if we counted all those up, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I missed one. What am I missing? There's actually 24. 4, 4, 4. Oh, right here. I just didn't write black on that one. If you counted all those up, there's 24 different cars, which matched our 24 that we got by using the fundamental principle of counting. So I'm going to stop there. If you want during the break, if you have a question, stay on so you can ask your question. And if you don't have a question, go ahead and go to the Chapter 3 review, the skills review for Chapter 3, because you're going to have to do that before you can get into 3.1. So do at least a few of those during the break so that after the break, you'll be able to get into your 3.1 homework. Okay, and I will see you at 12.